Good morning, good afternoon, and good evening, everyone, wherever you might be. Today, we're going to be doing our exercises with a mix of both equations of lines and planes in 3D. So let's just get started, yeah? Okay, so number one, uh, okay, so we have a true or false type of question. Okay, so we want to determine whether it's true or false. Okay, in R cube. So our first statement is that two lines are parallel. Oh, what? Two lines parallel. So there are two lines that are parallel to a third line parallel. What does that mean? Well, you have two lines parallel to a third line. Two lines parallel to a third line parallel. Is that true or false? I don't know. Let's just got the explanation and see what in the world does this mean? Yeah, I'm confused. Okay. The third line is parallel to the two lines. Huh. So there's this that is really complicated, in my opinion. All it's saying, explain this scenario, well, we have two lines parallel. Let's say this is L1, this is L2, and then we have a third line that's also parallel. This is L3. And now what this is asking if it's true or not, it's true. Why? Because their direction vectors are pretty much the same no matter how you scale it. And so let's say this is vector v, w. So we're saying that, oh, since um, L1 and L3 are parallel, right? So there's a notation for that. Those two vertical lines means they're parallel. So if those are parallel, then vector u is equal to some scale of w, right? Because they might have different lengths. So this is just a scalar. What else? Since L2 is also parallel to L3, so the red is parallel to the green line, then we can say, oh, L2, which has W, I mean, it could be V, doesn't matter, is equal to some W, but with some scalar D. And so here we can substitute that thing. Here we can get W is V over T. Um, yeah, so these are for some scalars. We're just saying that S and T are scalars, while U, V, and W are vectors. And so thus, U S of W, which is equal to S of V T, which is equal to S of T over V. Thus, L1 is parallel to L2. Yeah, because there's just some number at the end of the day. So U is equal to some number times V. So that's how we prove that L1 is parallel to L2. Yeah, this is a bit complicated, so I'm gonna admit I don't fully get it, but in context, I think this statement just means we're proving something that seems to be true. So L1, so this is true basically. So true, right? Okay, cool. Yeah, that's what it means though. So that statement is true. Now we have a different one. For the next one, we're doing two lines perpendicular to a third line. Oh, wait, we didn't complete it. Are parallel. Okay, I'm starting to get bit by bit. Yeah, so this means that given two lines, and they're parallel to a third line, L3, then those two lines are parallel. So here we're trying to prove that L1 is parallel to L2. We can say L1 is parallel to L3, L2 is parallel to L3, and here we can see, oh, L1 is parallel to L2 because of this formula. I meant to include the U. Yeah, seems to me that's how it works. Okay, so the next one is two lines perpendicular to a third line are parallel. So here we have two lines and they're perpendicular to a third line. But are those two lines parallel? The thing is, they could be. Let me try without doing any work. Here's a line. Here's another line. Here's another line. And here we have 90 degrees. So this is L1, L2. Let's switch up the colors. Okay, L1, L2. Then L3 is the one perpendicular. So L1 is perpendicular to L3. L2 is also perpendicular to L3. So we want to find, or we want to determine that L1 and L2 are parallel. Well, here we can kind of see the visual that this can be true. But I'm going to check just to be sure. But yeah. It's a false statement. Yeah, this is a bit vague. Okay, so example that was given was not this. Here they drew a coordinate plane. So no, coordinate space, X, Y, Z. And from here, we can draw L1. You can say this is one line, right? This is another line, L2. And then this is another line, L3. Now here you notice that two lines perpendicular, so two lines L1 and L2 are perpendicular to line 3, but are the two lines parallel? No, they're also 90. So this is false. That's all it's saying. Just kind of interesting. So that one's false, apparently. Okay. Two planes parallel to a third plane are parallel. So how do we do that? Well, um, here we can visualize. That's one plane. That's another plane that's parallel. Okay, that's parallel. Another plane that's also parallel. And then most likely their normal vectors are equal, right? So I'm gonna say this is true. Yeah. So if we're given, let's say, two planes, we're given plane 1, P1, plane 2, P2, and then the third plane, P3. Well, P1 and P2, if they're parallel, then they have the same thing, the same normal vector, which should also give P3 the same normal vector. So it's probably true. But again, it's just a guess. Um, at the end of the day, I can't really. So it's true. Okay, what's funny is the example kind of gave the same colors as the. Okay, kind of similar to this one. Yeah, here we're saying N1, some scalar, N3. Okay, N1, some constant, 1 over T. Hmm. Yeah, so we're able to derive N1 in terms of N2, and this is just some scalar, and so that means they're parallel. Yeah, Here it's basically mostly just proving. Okay, let's try the other one. So that one's true. Now let's try this. Do planes perpendicular to a third plane to a third plane are parallel? Wonder if that's true. You're given a plane. That's a plane. Now, what do you want to do? Well, you have two of them. Hmm. I can't really tell. I don't know how this is gonna look like. See, that's the thing. I don't think they are though. No, I don't think they are. This is probably false. Yeah, it's gonna be false. Just draw that. Okay. So xy is perpendicular to yz or xz, doesn't matter. Yeah, two planes. Yeah, here we are. Hmm. Oh, Lena, what am I saying here? Um, two planes perpendicular to a third plane. What part am I? I'm at D or E? Where am I? Oh, I'm at D. Okay, so we're gonna go through D. But here's just saying the XZ plane. Yeah, this XZ plane is perpendicular to YZ plane. XY plane, so this one is perpendicular to YZ plane, so this one. Oh, that's Yeah, here the idea is that even though the xz plane is perpendicular to yz plane, the and the xy plane is also perpendicular to yz plane, the xz plane and the xy plane are not parallel to each other, right? So again, it's just about thinking in 3D, right? Two planes perpendicular to this third plane, which is yz plane. And are these parallel? Well, no, because xz plane is this one, xz, xy is this one. So they're gonna intersect somewhere in this line, maybe. But yeah, this is false for letter D. Okay, now we have two lines parallel to a plane are parallel. So here we're given two lines parallel to a plane are parallel. Is that true or false? Well, if we have two lines that are parallel to, say, some plane, hmm. Honestly, I need to look at some visuals to see how that would look like. I think this is true though. Oh, it's false. Okay, I need to keep drawing this thing. X-axis, y-axis. Oh, so we're thinking of worst case scenarios. So let's say this is the x-axis, which is a line. This is a y-axis, which is also a line. And we can say that they're parallel to this plane above them, right? But are the two lines parallel here? No, but they're intersecting. So this is false. Yeah, I think that's probably the most simplest one. Two lines perpendicular to a plane are parallel. This one is probably true, right? If we try to draw another one of our coordinate, our space, so x, y, z, and we say we have a plane. Let's say it's just the xy plane. So that's the plane, and we have two lines perpendicular to a plane. So let's say one is this z-axis. That's a line. Let's say another one is, I don't know, here maybe, some random point that I don't know where it is. Yes, these are parallel. So I can't think of another case where it isn't. So I think this is true. Hopefully. These two lines are perpendicular to this plane, right? I could get their 90-degree angle here. But are they parallel? Probably. So I'm gonna say true. But I'm not super confident though. I'm gonna double check my answers first. So for A, we have true. For B, false. True, false, true, false, false. So true, false, true, false, false. Okay, for F, I'm gonna think for F that's true. Yeah, I just feel like it's true. Let's see. Yeah, it's true. It's true. I'm not gonna like prove it anymore. I'm just gonna make a picture. Yeah. Okay. Next. Uh, oops. Trying to put the thing down. Okay, for G, what does it say? Two planes parallel to a line. So we have two planes parallel to a line are parallel. So, okay, let's draw a picture, right? How would that look like? Let's say one plane is this XY plane. Um, let's say the line is here. And let's say another plane is up here maybe. So yeah, I guess they are parallel. I'm gonna say true unless it's otherwise. But I feel like this is true. So two planes parallel to a line are parallel. Uh, I'll check it for myself. Oh, it's false. Okay. Okay. Oh, yeah. I mean, I couldn't think of it anyway. So this is false. It's just tricky to find one. Yeah. So Yeah, see, I also make mistakes when I do math. I'm not like good, I'm not a good mathematician where I just get all of it correct. I sometimes get something wrong. Let's say the line is this x-axis, right? Let's say that's the x-axis. Now, one plane that's parallel would be this plane, which kind of goes like that. This is the plane where y is 1 maybe. And then another plane that is parallel to this line would be this plane that goes up. And now here, what do you notice? This probably z is 1 maybe. They intersect. So these two planes are not parallel to each other, but they are parallel to this line. So it's false. So two planes parallel to a line are parallel, not always, so it's false. Okay, next. Planes perpendicular to a line are parallel. So we have two planes, and they're perpendicular to a line, but are they parallel? Well, let's find out. Okay, so we have a line, and two planes are perpendicular to that line. Ooh, okay, that's interesting. How can we tell, actually, without even like 3D, what was that? We have a line, and then we probably have like what? Some plane that goes like this. Okay, my drawing is ugly. Okay, it's kind of slanted. Like that, maybe? And so, well, if we were to like connect this here, this is a perpendicular plane. Another plane would be another plane would be like this. Okay, in this case, this is definitely true, but I don't know. There might be a case where it's false. So we're gonna look carefully, or we're gonna watch the video. Because I can't really think of these stuff. Okay, it's true. Okay, so it is true. Yeah, I don't even need the space. I just it just gave me two planes. P1. Here's what it did. P2. And then we have a normal vector that's perpendicular. But it can also go down like that. So I can say, oh, we have a line here. Let's say line. And these two planes are perpendicular to this line. And so P1 is parallel to P2, so this is true. Right? So what's important, even though we make mistakes in doing math, is we understand what the mistakes are. Okay, next. Here we have, okay, is the statement true? Two planes, we're given two planes. It's either they intersect or are parallel. Intuition wise, this is probably true. If they're not parallel, then what are they? Then they intersect, right? Yeah, it's true. Yeah, it's only yeah. It's either we have them parallel, or we have them intersect each other. And if they intersect, they're either perpendicular or not, right? So we have some normal vectors here. Yeah, it's either that or they intersect somehow, and then they have this line that makes them intersect. So it's just either that. So it's either they're parallel or perpendicular, not perpendicular, or they intersect. Okay, let's go J. There. Okay, for I, this is true. For H, it's true, right? Yeah. For G, it's false. Okay, let's go to J. Two lines either. Oh, now here we're talking about two lines. So two lines either intersect or parallel. Well, this is false. Yeah, because you can have skew lines. This is false. If we were given some x, y, z in space, we can have like a line that goes here. We can also have a line that goes here to the other side. And here they're not parallel and they don't intersect as well. So these are called skew lines. Right? So this is false. We'll see. Yeah, lines could be skewed. Okay, next one, or this is the last one for this item. This is long. Holy crap. Okay, so for the last one, a plane and a line either intersect or are parallel. A plane and a line, uh, they either intersect or they're parallel to each other. So here, if we're given a plane, we're given a line. Um, I'm gonna be honest, I can't think of one where this isn't true. So I'm gonna say this isn't false, so I'm gonna say this is true for now. But unless it thinks of one, then if the video has an idea, yeah, it's true. Yeah, it's either the line and the plane intersect, or they're parallel. I can't think of one where probably when there isn't a line. No, I'm kidding. But yeah, I can't think of one where no, I can't think of one. Okay, so K is true. Yeah, I'm kind of worried about the proving part, but anyway, I mean it's nice to prove some stuff once in a while. Okay, let's. Oh, okay, my that's funny. That's weird. I tried to submit, but okay, wait. Hold up. Let me check my answers real quick. So true, false, true. So true, false, true. Then starting at D, D, E, F is false, false, true, false, false, true. G, H, I, starting at G, false, true, true. So starting at G, false, true, true. J, K, just kidding. J, K is false, true. Okay, so let's see what happens. Okay, yeah, I thought my homework would have an issue. Anyway, uh, now let's actually do some math here. Okay, so here we're gonna start off with finding equations of lines. So we're gonna find parametric equations. And I don't know why my pen's working that way. It's kind of weird. We're gonna find parametric equations for a line through you were given points 3, 1, 8. What else do we know? Uh, this line is also perpendicular to a plane. Plane x minus y plus 4z equals 9. And we use parameter t. Okay, so it's been a while since we've done equations of lines because we've been doing equations of planes. Okay, so what do we need for a line? Well, we need the initial point. So we need a point. Boom, we have it. And now we need a vector, a direction vector that's parallel, right? Okay. So for lines, we're gonna want to find a direction vector v. I think it was v, right? We're gonna look at this. Yeah, because this one's parallel. So we were able to find um what's this? Yeah, because this one's parallel. Well, if it's perpendicular, okay, that one I don't know. Yeah, I'm looking through my old problems. Okay, 2 points here. Oh, look at that. If it's perpendicular, Um, what does that mean? I get the cross product. Hmm. Where do I get the cross product? I have a point, plug it in. How about this one? Find symmetric equations, find points, uh, whether lines L1 and L2 are parallel, skew, or intersecting. That was the hard one. Um, yeah, I'm thinking here. Okay, because it's perpendicular to this plane. Um, maybe we can draw? Maybe. We need that direction V though. How do we do that? Okay. Let's- Hmm, okay. Yeah, you want to get the normal vector. Since this, oh, oh, actually, since the direction vector is supposed to be parallel, and here if we look carefully, we have a line and it's perpendicular to a plane. Let's say this is the plane, right? And so what is this? This could be our normal vector. So this the normal vector, so that's what it means. If this was our line, what we're saying is the normal vector n of plane is the direction vector of the line. So that's that. So we just got these numbers here, 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 and here. So our vector v has that. 1, -1, 4. Done. Okay. Now we need a point. We already have a point. 318. I don't need to write that. Use or not even formula. Just find parametric equations and that's it. Yeah, we can easily just plug in the stuff that we need here. So this is x is equal to the point, so x naught, so 3 plus vt. So I'm going to multiply this by t. Y is y naught plus bt. So 1 minus t. Z is 4 plus, is it plus? Wait, why did I say 4? It should be 8. 318 here. And then plus 40. Done. That's it. 3 plus t, 1 minus t, 8 plus 40. There. Done. Okay, let's plug it in, see what we get. And from there, we can find vector equations. A vector equation, we can find the symmetric equation. Depends on what we need to find. Okay, so plug that in. 1 minus t, was it? Equals 4. Yeah, I'm just gonna submit, see what happens. Nice. Okay, next. Well, not next number. Next, like, sub problem. The reason why is because there's an A and then there's a B. And what points does this line intersect the coordinate planes? So in what points does this line intersect the coordinate planes? So the coordinate planes are xz plane, yz plane, xy plane. Well, we'll just take it step by step, right? So for the xy plane, what points given that line? Well, we put conditions, right? So for the xy plane, z is 0. And if z is 0, then if z is 0, then all of the possible points that we can get is x of t is still the same, right? Actually, no, I have a point already. Yeah, I already have a point. If z is 0, then we do 0 equals 8 plus 4t. And then we get some t here. So t is basically what? We can solve it. So this is -8 for t. We can divide both sides by 4. So t is -2. Right? And now we can plug in that for x and y. And we can get the point. So let's just plug it in. So my x at -2 is 3 minus 2, which is 1. My y at -2 is 1 minus -2, 1 plus 2, that's 3. And so a point would be that. So 1 for x, 3 for y, -2, not -2, 0 for z, right? 1, 3, 0, 1, 3, 0. Let's swim and see what happens. Yeah. And same idea. For yz plane, then we just make x 0. So here we solve for t. T is just -3. And then we can plug something in for y and for z. So y of -3 is 1 minus -3. So 1 minus -3, 1 plus 3, 4. For z of -3, then that's just 8 plus 4 times -3, 8, 8 minus 12, 8 minus 12, that's -4, right? So that's it. The point is 0 for x, 4 for y, -4 for z. And lastly, we do an xz plane. So here we just have to make y 0. 0, we solve for t here. So 0 is 1 minus t. So t is 1. If, not if, x of 1 is 2. No, is 4. 3 plus 1 is 4. And then z of 1 is what? Z of 1 is the function. 8 plus 4, 12. So a point would be 4 for x, 0 for y, 12 for z. Done. So those are the points uh, of this line when they intersect the coordinate planes. So let's just type these out. So we have 0 for -4. If the line intersects the yz plane, for the xz plane, it's 4, 0, 12. Okay, and this should be good, maybe. Let's see. Nice. Okay, number 3. Finally, we moved a number. Find an equation of the plane. Oops. Okay, let's chill. Uh, what do we know about this plane? So this plane probably passes through the point. Okay. Uh, the plane passes through, so it's not a point. The line of intersection. What does it intersect? Oh, of two more other planes. Okay, so it passes through the line of intersection uh, of the planes. X minus z equals to, and so it's combining stuff here. Y plus 3z. Not gonna visualize this. This is hard to visualize. So this information is probably where we'll get our point, somewhere here. And this plane is also perpendicular to another plane. So clue about perpendicular. Probably this is probably where we'll get our vector, our normal vector. Uh, X plus y minus 2z. Yeah. So if we really split this statement into pieces, we decompose the statement, we'll probably get something here. So first we have to find a point. That's what we need. How do we do that? Well, it passes through the line of intersection of these two planes. Pretty sure we had something like that. No, I'm not even kidding. We had something like that. A line that intersects two planes. No way, I didn't do anything like that. Cool. Okay. Um, yeah, that's really nice. Okay. Uh, equation of plane passing through 3 points, cosine determining whether they're parallel, perpendicular. If they're perpendicular, my initial idea was given those two planes, can we figure out what line is it? Did we do something like that? No, I don't think we did. Can we though? I don't think so. Okay. Yeah, we did this before. We are. No, I don't think we did any. Okay. Hmm. Let me think. So, a plane that passes through the line of intersection of these two planes. What can we do about those two planes? Well, there's hmm, line of intersection. Line of intersection. Maybe like they both have a Z in it. Hmm, line of. Okay, how about this? Um, I'm not sure if this is gonna work. What if we find a point of intersection in those planes? Because I don't think we ever did like, oh, given two planes, they intersect, they form a line of intersection. I don't think we've been able to derive anything like that, you know? We can, I think we can, but I'm just not sure how to do it. I don't know. Yeah, I don't think we've done anything like that. Or have we? And I just forgot. Like I totally forgot about it. Have we done anything like that? In the textbook, maybe. There's some exercises here. No, these are lines. Um, for planes, finding intercepts, 3 points, intersecting a plane. Um, no, I don't think we've done anything like that. So, hmm, oh, would you look at that? For the line of intersection L of these two planes, find the point on L. How do we do that? Are we given to? Oh, oh, would you look at that? We find the point, that line, by using the plane equations. Yeah, I think we can do that, no? I think, I think, I think we can do that. Yeah, that's what I was thinking. Like, what if we just do that? Like, let's say, oh, okay, if we're given the the two planes here, we get a point by just plugging in numbers here. It could be any point, to be honest. Let's try it. Let's try it. I want to see how this works. If not, then I give up. So we want to find a point on line of intersection. And so I can say z is 0, just to make my life easy. Then what can my x be? Then one of the planes, x minus 0 is 2. So that means x is 2. Another one is this. So I got this idea from here. And then another idea is this one here. If I make z 0, I can find a value for y. Y plus 3 times 0 equals 1. And so y is 1. And so a point on the line and both of the planes. And what else? That plane passes through the line of intersection. And so it also passes through this point because this point is on the line of intersection. So now we have that classic problem where it passes through a point. Right? This is 2, 1, 0. Done. We have our point, finally. Now we find our normal vector, which is easier. Let's just denote it as n. And so how do we do that? Well, it says here that plane is perpendicular to another plane. And what does it mean? Well, let's say this is the plane we have, but we don't know the equation. This is the other plane. I can't draw. Then this is perpendicular. So we can just get the normal. No, wait. Am I right? No, I think I'm wrong. Wait a minute. Oh, shoot. Because this is perpendicular. Uh, never mind, never mind. Yeah, that is tricky. Yeah. Wait, let me see. Yeah. That, yeah, that's tricky. Yeah. Okay, this is tricky. Never mind. I tricked myself into thinking it was easy. Um, how can we now find the normal vector? It's perpendicular to the plane. Uh, if it's perpendicular to the other plane, this other plane has this normal vector, which is parallel to the plane we have now. But how does that help, right? That's tricky. Any way on doing that, maybe? Uh, Let me see. There should be a way. If there isn't, then why bother giving a problem like this if it doesn't work? Uh, yeah, it doesn't. No, I can't. I can't. Uh, yeah. I don't have a point. Hmm. Let me think. Find the angle. That was tricky. Okay. Since L, after this, I'm gonna cut the video because it's gonna be too long. Okay. I'm still trying to figure this out. Once I figure this out, then I'm gonna cut the video and I'll move on to the next one. Oh, we're only given lines. Yeah, this is tricky. Okay. Uh, find the distance between parallel planes. It's hard when you're figuring it out on your own. Uh, parallel. I'm just finding distance. It's not this. Yeah. Uh, is it in one of these? No. Yeah, what if it's perpendicular, huh? Okay, yeah, that is tricky. Probably one of the most tricky ones so far. Let's see. Okay. Hmm. Oh wow. A minus x naught plus b y minus y naught b b minus b naught equals 0. Normal vector and b naught as points x naught, y naught, z naught is 0. Point normal form. Yeah. So the first, okay. So I'm being asked to find a plane that passes through the line of intersection of the two planes. So that was our first step. And it's perpendicular to another plane. Now, the first step was to find a point on the line of intersection, which we did. And we did try z equals 0. And so we got a point on the line, which is 2, 1, 0. So that's done. Now we need to find a normal vector. Oh, wait. So that's the line of intersection of. Wait a minute. If we're given two planes like this, I don't even care about my drawing. This is the line. What? Find the direction vector of the line of intersection. Why? And we are able to do that by taking the cross product of the normal vectors of the two given planes. What? Okay, that's something. I didn't know that. Mm, so we have like our two planes here, right? We have our two planes. Let's say these are the two planes. And we want to get their vectors that go up like this, right? And then they form a theta here. Um, How does that work? Oh, wait a minute. Wait. Let me draw this a bit nicer. We have these two things, right? These two planes, and their line of intersection is this one. And what do I want? I want a direction vector of the line of intersection. I'm still trying to figure out why. We find the direction vector by taking the cross product of the normal vectors of the two given planes. So here we have uh, one normal vector from one plane, another one from here maybe. And uh, if I keep going up here and keep going here, then I have some angle here, theta, same angle theta here. And what else? Uh, I can't really visualize it, but the idea is we can actually get the vector here if we get the dot product of n1 and n2. I'm still trying to figure out why. Why, why do we need? Okay, cool. Let's say we did get that. Now we want to find the normal vector of the plane we want. And we're told the desired plane is perpendicular to another plane that was given. Okay. Interesting. Okay. This is tricky. Very tricky question. Okay, we found a point. That's good. Now, the next thing we want to do, I'm not even going to bother. Uh, so apparently, the next thing we want to do before finding a normal vector n is we want to find a direction vector. So a vector that's parallel to that line of intersection. Or not to, off. So we want to do that. So how are we going to do that? We find the direction vector by taking the cross product of the normal vectors of the two given planes. So let's say our P1, which was this plane, x minus z is 2, has a normal vector n1 of what? Well, 1 for x, 0 for the y, negative 1 for the z. Done. Now for plane 2, we have y plus 3z is 1, and so our n2 is 0 for our x, 1 for y, 3 for z. And now we get some sort of cross product here. So let's just say that's a v. We get a cross product here. 1, 0, negative 1, 0, 1, 3. And we can get uh, I, j, k. Now we can cancel out some stuff. 0, let's see. So this is for I, 0, negative 1. So this is plus 1, right? Next, we can take out all the j's. So we got 3 minus 1 That's 0. And then we can do k here. They do, wait a minute. Okay, I did j earlier. I'm gonna do k. This is 1 and 0. And so here we have a vector, or not yet. Let's just fully write it out just to be sure. You have a vector 1, -3, 1. Right? And so that's the direction vector. Now after that, what we now want to do is find the normal vector. Yeah, so this is a bit more extra stuff. Um, we're told the desired plane is perpendicular to this thing here, right? So we're looking at this piece of information. Still don't know why we want to get the direction vector. I'm gonna be honest. Yeah. Okay, let's go for it. So we're told the desired plane is perpendicular. So the desired plane must have a normal vector that is perpendicular to the normal vector of that plane. Yeah, a lot of tongue twisters, but basically, we have the normal vector of this guy. And so we have that normal vector. We want a normal vector that's perpendicular to the normal vector of this one. Now, that's an issue because I don't know how to do that. But yeah. So that's where our direction vector comes into play. Oh, okay. Yeah, that's smart. So let's say N3, or let's just do like what? Normal vector of third plane, N3 is, well, based on here we have 1, 1, -2. That's it, right? What else? Um, Now we want our actual normal vector for our plane that we're trying to find. And so we want that to be perpendicular to this direction vector here. Unbelievable. Could never have thought of this, but yeah, it's creative. Let's be honest. This one's really creative. So yeah, we can get the um we want to get a vector that's perpendicular to the direction. Yeah. Why is that though? You have two planes. We got a point. Check. You got these two planes. I'm thinking. Yeah, usually a visual would help. I mean, if you guys can give me a visual, that would be greatly appreciated. But for now, I'm gonna work with this. So yeah, we have 1, -3, and 1. And then we have this third plane. And so to find n, then we get the cross product of those two. So n is just the cross product of those two. So that's v, our direction vector v, and our n3. And so that's going to be, again, another cross product in this case. Yeah. Okay, I'm gonna continue this, but I'm gonna cut the video for now, and I'll see you all in the next one.